Hey guys, Mr. Mackey here. Now yesterday I introduced you to scattergrams and correlations, and I showed you this scattergram that we created thanks to this data. Now from this there is a strong positive correlation, therefore we can conclude that maths scores leads to an increased hair length. Now I asked you to think of a possible problem with correlations and scattergrams based on that conclusion. So here's a question for you. Do you really think that higher maths scores will lead to a longer hair length? Well, it could result in loads of other factors. For example, you might not have been to the hairdressers for a long time when you did that maths test. Or you could be a girl where your hair's longer than boys anyway. So the problem we can get from correlations is it doesn't always mean there is an actual relationship. Higher maths scores even though it says it doesn't mean that higher maths scores are actually related to longer hair length. So we can't always trust correlations in this fact. So the criticism that I wanted you to think of was that correlations don't actually mean that there is a link, even if it says there is. You just need to use a bit of common sense and think, do maths really lead to hair length? Now today we're going to be looking more into correlations and making some interpretations from them. And alongside that, we're going to be seeing the difference between strong positive, weak positive, and even look at ones with no correlation. Let's check it out. Now, when we find correlations, how we usually test for them is we use a correlation coefficient, which is known as R. I don't know why, probably because there's two R's in correlation. Now, this correlation coefficient must be between -1 and 1. Because this is a sort of percentage, it's the sort of certainty aspect of it. Pardon me. Now, the reason why we go from -1 to 1 is, well, it's kind of obvious. When it's between 0 and 1, it means it's a positive correlation, because the numbers there are positive. And when it's between 0 and -1, it means our correlation is negative. So, one thing that you might be asked to do whenever you see correlations is make a prediction on what you think the correlation would be in the sense of what R is. So when you look at this, you can see that already it's positive, which means it's going to be between 0 and 1. So the next question we ask is how strong this correlation is. Well, they do seem to be forming a considerably straight line, so we can assume from this that the correlation will be quite close to 1, but not very close, because we can see some parts of it a little bit spread out. So my prediction of how it would be is as long as you get it within this range, I would say that the R would be 0.8. It's strong, but it's not completely strong, and it takes into account that it does have some bits sticking out. But this is a very accurate correlation, and this shows us it is a strong positive. Let's look at another one. Now in most cases they will give you a selection of different correlation coefficients, and they want you to find out from this correlation which one best works for it. So, which correlation coefficient would this scattergram represent? Well, what we can first say is it's definitely not going to be 2.1. How do I know that? Well, it has to be between -1 and 1, so it can't be that. So what else could it be? Well, this is going downwards, which means it's a negative correlation, which means it can't be 0.8, 0.13, or 1. Now, because of that, the reason why I cross those out is because those all represent positive correlations. And of course, this is not positive. Now, even though we can see it's going down, the x's are actually quite spread out. They still form a line, but not the most consistent line. So we conclude it will not be a strong negative correlation, so it will not be -0.7. So now we're left with these. Now, -0.01 tells us that this correlation has practically no correlation to it. There's not even a sign that it's going one way or another. However, we can tell that there is a negative correlation. It may not be the strongest, but it is negative. So the best one to say for it is -0.4, because it's weak, but it's negative, which this tells us not. So this is the best correlation coefficient for this. So whatever the two factors are saying, it is arguing there could be a link between X negatively influencing Y, but it's not the strongest, so we can't really trust it. Let's see another one. So what about this one? Well, firstly, we can say it's not going to be 3.6 because our coefficients must be between -1 and 1. Now, from this, can we see it's going up in a certain direction or down in a certain direction? No. So we can already tell it will not be strong either. So let's rub out our 1 because that shows there's a strong positive, and -0.7 because that shows there's a strong negative. So it could be any of these three. Now, this doesn't even tell us that there is a strong or negative. This doesn't even tell us there's a positive or negative. So it's very close to 0. And so these won't work either because these do show us a faint sign that there could be a correlation. So the best one that actually represents this scattergram is 0, because that tells us there is almost no correlation. So what we can infer from that is that X has no influence whatsoever on Y. Now, because this is Sunday and we do our challenges on the same day, let's look at the challenge I've set you for today. Now, the thing with statistics is we have to do explanations. We do have to put some answers, and we do have to work, and we do have to actually write some things sometimes. Now, for this is the first example of how we will be writing in statistics, where you have to provide evidence to support your argument. So, I want you to fill in the blanks based on the evidence that this graph is telling us. I'm going to give you 3 seconds, then we're going to fill in the blanks. 3, 2, 1. Let's do it. So, this scattergram is clearly negative, but I wouldn't call it strong because there's a lot of spread out. So I would call it there is a weak negative correlation. So as X increases, Y decreases. But it doesn't mean a link. So what I've just said is there's a weak negative because they're quite spread out. So this would be somewhere between the 0.4, 0.6, negative 0.4, 0.6 mark. So there's a weak negative correlation. So as X increases, Y decreases because, you know, that's what negative correlations do. But then I also put it doesn't mean a link because correlations don't always have a causal relationship. And also because it's a weak correlation, there may not be a link anyway because, you know, it's not that reliable. So we have 2 weeks left before the end of this academic year. And that is going to be when I'm going to stop doing these videos. Because I know in September, as far as I know, schools will be reopening. And so I'll be going back to my full-time job as a teacher. Now, because of this, I'll be doing 2 more weeks of videos. I'll be doing a topic to next week and a topic the week after. I haven't decided what they're going to be yet, or maybe have I, and I want to surprise you. If the lot schools do close again, if there's a second wave, which I hope there isn't, then I will still do these videos. But at the moment, because you guys probably won't be working during the summer holidays, because that's what summer holidays are for, I'll give you a break, and then when back in September, we'll all be back in school anyway, so there's no need for my videos anymore. I hope you've enjoyed this channel. I'm looking forward to doing these last 2 weeks and to do maths in the future. But take care of yourselves, and let's bring on the final 2 weeks of Mr. Mackey's Maths. Have a good Sunday, guys.